This is All Things ANSYS, a podcast from the technical support staff at PADT. Episode 54, an interview on the state of CFD today, along with ANSYS-related news and events. Welcome to our first podcast for 2020. My name's Eric Miller, and I'm one of the owners here at PADT. 2019, which just ended, was a special year for PADT. It was, as you know, if you've listened to the podcast, our 25th anniversary, and we enjoyed celebrating that with all of you. And it was also, from the ANSYS side of things, the most new ANSYS customers that we've ever added in a single year. So we continue to add new users and new companies across the southwestern United States, and I'm glad to have all of them and all of you involved in our journey here in the ANSYS world. And one last time, I'll mention how excited I am about the LS-DYNA acquisition. Looking forward to 2020, which I'm still having trouble saying. 2020. Questions that will be answered. Who will ANSYS acquire next? What new features will change the way we do simulation? Will I be using 5G on my cell phone at some point? Not the 5G that just puts the logo up in the corner, but real high bandwidth 5G. Very excited to see that. Of course, a lot of ANSYS tools used in the development of the 5G network that's being installed all over the place. And please do stay subscribed to this podcast to see us through, come with us on the journey of what is going to be 2020 and see the world through the ANSYS tinted lenses that we watch it through. And I'm going to talk podcast statistics after the interview. And to speak of the interview, back in July, I was the guest of a person named Robin Knowles, who hosts a podcast in the UK called CFD Today. As the name implies, it's about CFD. And I never had a time after that was recorded to share it on our podcast. And here it's the beginning of the year, and we're still waiting for ANSYS 2020 R1 to come out. So we actually have an open spot. So I thought we would edit that thing up and stick it in here in the middle of this podcast. So please do enjoy my discussion with Robin, where he's going to ask me some questions and we're going to talk about CFD.
Welcome back to another episode of Talking CFD. And today I'm joined by Eric Miller, fellow podcaster and one of the co-founders of Simulation Experts PADT. Welcome to the show, Eric.
Oh, thanks for having me.
No trouble. Now, I know that PADT stands for Phoenix Analysis and Design Technologies. I know that you guys do more than just CFD and that you've been doing it for a while, but I don't know too much more than that. So can you bring me or us up to speed on PADT today before we wind back to the beginning? What do you guys look like today?
It's the biggest problem we have is telling people what we do. The answer is everything. So we focus on, we have three different divisions. The first is focused on simulation, and we do full physics. We do CFD, mechanical, structural, all that stuff. We do high frequency electromagnetics. We do some piezoelectric, and we kind of combine them all together in multi-physics. And we do consulting for that. And then we're also a channel partner for ANSYS in that area. And then the next area is our design group, where we do full product development for folks from start to finish. Our favorite thing to do is early stage conceptual stuff, because you don't have to necessarily get it right. You just get to have fun. And then, but we'll take it all the way to production for the customer and help them through production. And then our third group is focused on 3D printing. And we're a Stratasys reseller as well as a service provider for 3D printing. So we have about 13 machines and we make all sorts of plastic parts, and we're starting to make metal parts. So we basically kind of do whatever a company that produces products needs to do, but real focus on simulation, 3D printing, and kind of advanced design.
Does sort of simulation span all those different areas, though? You kind of doing simulation around the 3D printing as well and kind of fully integrated?
Yeah, starting to do that. It's been something we've wanted to do for some time. We haven't really had good tools for simulating the whole 3D printing process, or even the parts when they come out. It's been kind of a pain in the butt. But over the last 3 or 4 years, we've really started to do more and more of that. And that really is a differentiator. What we tell people is, we're a company that can do all three of those things. So if we're doing design for you, we've got some of the best simulation people in the world just in the cubicle next door, and we've got in-house 3D printing as well, and vice versa. We often make models of things we do 3D printing of, or that we do simulation of. At the end, they go, "Well, can you change the design? Can you print it?" And we can do that. So it's a lot of fun to do all three, and And kind of our origin story is the reason why we do these three things is not necessarily just a lack of discipline, but it's also that's what we all did 25 years ago when we started the company. So the three of us that started the company worked at what's now Honeywell Engines. It was at the time Allied Signal, and they make the Garrett turbine engines and Garrett turbochargers, as well as air research equipment as well. And we were doing internal consulting. We did simulation, we did design, we did 3D printing for the rest of the company as kind of an internal consulting group. And we decided that we would start a company based upon those three technologies, which back in 1994 were very new, very unproven, and very rare as well. So we thought we would build a company around those three technologies, and here we are today, still doing them.
Yes, I mean, I'm imagining things have changed quite a lot over that time. But I mean, obviously there was some buy-in when you were an internal group. Was it difficult to kind of net those first customers, find some believers?
Yeah. Internally, it was really hard when we were still working within Allied Signal. Simulation costs a lot of money and not necessarily gave you the right answer. And most of the project leaders had paid for simulation and not got anything out of it, so they were kind of against it. The 3D printing was easy. 3D printing's always been easy to get people to go for because it's just so cool.
Okay.
And then advanced design. When I started, we were still doing 2D drawings, and we were really pushing 3D solid modeling. And then parametric solid modeling. That's kind of where we were on the leading edge, was the whole idea of building these parametric solid models of turbine engine components. And that was very much an uphill battle. We started the company even more so because aerospace was starting to adopt it, but outside of aerospace, it was very much a 2D world. It was very much a build and bust, no prototyping, no simulation. And so, yeah, it was a long haul. It took about 5 years before we kind of established ourselves outside of the turbo machinery business. And then it's just been growing since then.
Is that still a core element of the business, though, the turbo machinery?
Yeah, small turbo machinery, not necessarily.
Okay.
The big guys. Yeah, the big guys have their own capabilities, right? So they don't need us anymore. What we do for them is we write software to customize some of their processes. We do training, we do mentoring, we do support. Every once in a while, we'll get an overflow job from them, but they're pretty well taken care of. They don't need to outsource too much. So where we do a lot of turbo machinery these days, and where we apply a lot of our CFD is small blowers and pumps.
Okay.
And so really taking that experience from a high efficiency side and taking a product that's just not quite there from a performance standpoint and getting that performance where the customer needs it.
So are we talking turbochargers, small gas turbines, that sort of thing? Or
a little bit of that, but mostly moving air gases like hydrogen for fuel cells.
Oh,
okay. We've dabbled a little bit in some aerospace applications, which I can't talk about, but we're moving fluids around again. And the efficiency is there. We've even done some custom pumps for the gasoline or the petrol in your world business. So there was a guy that wanted to put the tanks much deeper in the ground, so he needed a bigger pump basically. And we designed that for him, and it's actually a patented thing, and now he sells them to truck stops around the world that want to bury their tanks deeper.
So what would you say the kind of the split is at the moment between sort of project work where somebody might come to you with a discrete thing that they want fixing, and kind of where you are somebody's sort of R&D group, if you like?
Yeah, it's about 50-50 on the design side, where we're about half the time we're kind of doing their R&D, and the rest of half the time they've got an existing design, and we're just kind of figuring out how to make it better, or a lot of times it's finding the problem. A lot of our simulation work is that area. We've got a couple projects now where they're complicated thermodynamic issues that are CFD and structural and thermal, and the performance just isn't there. So being able to see inside with simulation, we're able to help the company understand why the performance isn't where it is.
Although I haven't done a lot of work in that particular world, I'm guessing that in a lot of circumstances the problem isn't necessarily exactly what they thought it was in the first place.
We're almost always wrong. Yeah. They're wrong. We're wrong. And it's always some sort of a swirl or a turbulence or a pressure distribution that you just didn't expect. And a couple of these recent applications have involved combustion as well as pumping and things. And so, understanding how things are mixing, pre and post ignition is not intuitive. And that's what we're finding. So it's got a lot of fun. We get to play with baffles and things and fix these problems, and much easier to do a simulation than test.
It also doesn't sound like what you might call low hanging fruit. This sounds like you've got to the trickier to pluck stuff. It's getting complicated up there.
Yeah. The software, as you know, has gotten so much better that users are capable. You don't have to be a full-time simulation person or have a PhD to do CFD anymore, right? You can really get good answers. The tools across the board from high to low end are so much more easier to use. So we're not seeing those problems. And when we do, I'll be honest with you, every once in a while we'll come in and we're like, yes, this is easy. We're going to knock this out of the ballpark. The geometry is the problem. The reason why they outsourced it is they couldn't get the geometry right. So we'll spend 2/3 of the time trying to mesh the dang thing. And sometimes not. I think the only time we failed on a CFD job in the last 5 years has been we could never get the whole thing meshed. It was a gigantic, let's just call it a science experiment that they were trying to replicate. And do CFD on the cooling for this giant science experiment. And we could just never get it good enough. There's your classic problem of tiny little features on a huge part.
Yeah, absolutely.
And
scale.
It just within the resources of what were available to us and them, we just could never get it to go. So we ended up simplifying the problem and solving it, but we could never get the big thing to go.
Cue loads of meshing software vendors contacting you after the show.
Yes, they can give it a try. It's a great test case.
What kind of split do you have now between people working on problems like that and then people putting workflows and processes together to kind of improve efficiency of the actual CFD as opposed to a part or a design?
Yeah, in our consulting team, I would say at any given time we got about 30% of our work is automation or process improvement. I'd like it to be more. We actually like those projects. We like writing software. We like, getting deep and teaching the customer to fish, and giving them that tool that lets them be more efficient. And so at any given time, like right now, I think we've got 2 projects going in that area. And they're both, ironically, turbo machinery. Right now.
Okay.
So we're helping people streamline that process of modeling that complicated geometry quickly.
Yeah, because within a given company or something like that, you tend to find that people do a lot of the same thing. So there's definite benefits to be gained from putting those processes in place. It also sounds a little bit like the sort of things that you're working with, it doesn't sound like I can't think of a tool off the top of my head that would do all of those things. So do you spend a lot of your time making tools talk to each other?
Yeah, that's all we used to do. In fact, my whole rise to, I won't say fame, but I got recognized early in my career because of my ability to hook tools together. And that's all we did, right? We wrote our own code to do everything. Other than Solver, we had to hook everything up. Now, not so much. What we spend most of our time doing is automating on top of the existing tools. So as an ANSYS reseller, that's generally fluent on the CFD side. If it's turbo machinery, it's CFX. And so we're writing things on top of them. Even on the multiphysics side, it pretty much handles the interaction between tools fairly well now. So the days of, writing all this Python code to string everything together, unfortunately fading because I really enjoyed doing it. But good from a productivity standpoint. We don't have to do that anymore. So it's less and less of an issue. What we're really looking at doing is automating the process using the existing tools, and don't have to write as much as we used to. The only area that we're still doing that is every once in a while we get a project where we're combining test and simulation.
Okay.
So taking test data from a rig or something, and then giving a tool to the product engineer that they can take CFD from their CFD expert and test data from their test guy and combine the two and then tweak the CFD till it matches the test data. And that's a lot of fun. And that requires a lot of stringing together code, which is fun.
Oh, you want to get it? You're in the middle of that fight, are you?
Mm-hmm. Yes. Well, this customer decided the test is right, so we didn't have to.
The customer's always right.
Yeah, the customer's always right. We're like, I think the CFD is actually right, but oh well.
I suppose one of the good things these days is if you wait around long enough, ANSYS will buy the functionality. You buy a new tool in or develop something new that'll do what you need anyway.
It certainly has happened. We ran into that most recently on icing.
Okay.
So we were helping customers do ice buildup. Yeah, ice buildup, and we were doing like you said, we were hooking together FenSAP, which was kind of the leading code for that, to ANSYS. And then all of a sudden, they're very good about not sharing that they're acquiring somebody. So we had no idea. Next FenSAP meeting, we're part of ANSYS now, so you guys don't have to work on this anymore. It's going to be built in. We're like, okay, cool. But yeah, if the customers really need it, they will do that, and they certainly have been on an acquisition binge lately, but more on the electronic side recently. So it hasn't impacted us as much.
But you guys are not developing sort of in-house solvers and things like that?
Last solver we did was a really specialized thermal solver that we probably could have gotten an open source one, but we just decided we'd write our own so we didn't have to deal with it. Finite difference. But yeah, in general, we hardly ever do any kind of solver design anymore.
Any company that's been around long enough, there's a solver writing project somewhere buried deep in the archives.
Yeah.
Or a mesher.
A lot of our guys on the CFD side have solvers from their PhD. And I know they've got them on their machines. They don't admit to it, but I know they're sitting on there somewhere. Because I know the Fortran compiler gets used every once in a while. So yeah, my favorite is, we have Ping Golf here in town. I don't know if you've heard of them, but they make golf balls and golf clubs and stuff. And they're actually owned by a former turbomachinery aerospace engineer.
Oh, really?
And so, yeah. The guy that started the company was a golfer who also worked for GE. And, so they apply a lot of they've always applied a lot of high-end engineering. And there's a lot of PhD theses from Arizona State University that have done some great CFD on golf balls and golf clubs and some really cool, spinning ball with dimples on it, traveling through the air stuff. And so a couple of our CFD users, that's how they learned CFD, was on a Cartesian code that they used to do that. And it's pretty cool stuff. Yeah,
sometimes the internal codes, the highly specialized things in some of these places really are quite impressive.
Yeah, what it's able to do and solve, and this was before GPUs. I think they're rewriting it right now to use the GPUs. They're going to be able to do some pretty amazing stuff.
Just somebody needs to lever it out of there.
Yeah.
So I mentioned that you guys have been doing this for a while. Is it your 25th anniversary this year?
Yes, it was. Yeah, I can't believe it. I only aged 15 years in that 25 years because of relativity, but yeah.
So back in the early days, was it just the three of you? Did you say?
Yeah, there was a fourth person that lasted a little while. It was the small business was not their thing, so they parted early, and then it was just us, and we used our former coworkers as night workers. We kind of used them to fill in the gaps and earn a little bit extra money for the first year or two, and then we hired our first employees, and it's kind of hard to remember all that, but yeah. We started I used to do almost all the simulation myself back then. And I don't know if I could do anything more than teach a class today. If I had to do a real model, it would be tough.
I'm thinking in those days would it have been in-house compute as well? Yeah.
So we were really lucky in that we had built good relationships with a lot of hardware vendors when they were trying to sell to this large corporation called Allied Signal. And when we started the company, they were really nice. They didn't give us anything, but they sold us their demo boxes. So we had an HP, about a 2-year-old HP UX workstation, and 2 SGI Irises, which are slower than probably, my watch. But at the time, those were pretty high-end boxes, and I think we paid like $10K each for them. It was before the Pentium came out. So that's what changed everything, is when Intel came out with the Pentium, the PCs we started shifting to the PC.
At least with the SGIs, if you picked them up, you felt like you were buying something by the pound.
Exactly. You felt like you were buying something by the pound. And it had that cool flight simulator, which we did spend a lot of time before we had customers playing with. So, we had a lot of fun with that. Those machines were way ahead of their time. They had video, they had audio, but it was all proprietary, right? So
yeah, absolutely.
Early internet days, we weren't really doing any work on the internet, but we were starting to get email and things like that. And, it all kind of, we didn't really pay much attention to it. It just kind of happened. And next thing you know, we're buying Pentium 2 boxes for $2,000 that are twice as fast as the SGI. And we never really looked back. So
do you guys still do most of your compute in-house?
We have until this year.
Okay.
This year we've been using a company called Nimbix.
Oh, yeah.
There's about 3 out there. I think Rescale's another one. And then Ansys has their own cloud solution, which runs in Azure. The problem has always been that these cloud providers just don't get HPC. No. So I'm running on a web server that's got a virtual machine on it. It just wasn't working. So they finally figured that out. And Nimbix has really got some really nice hardware. And we have some customers that run on some of the other places. We've been testing the Ansys cloud. It's been working really well as well. So, I think we've bought our last large cluster.
That's interesting.
For now, these pendulums swing back and forth.
Yes.
The nice thing is we can probably run 80% of our CFD on our desktop machine. Okay. It's like maybe an 8 core box or maybe a 10 core box where we use 8 cores, load it with as much memory as we can. Most of the CFD we can run on that. Then we got what we call desk side servers where we'll have maybe 48 cores, and the vast majority of our work will run on that. But when we need to go bigger than that or we need a faster turnaround, now we're going to go to the cloud. We built a server room that's really pretty and it shows great on our tour, but I think there's like 4 boxes left in it. It's just a giant empty rack.
Loads of flashing lights.
The lights are all gone now. There's like 4 lights flashing now. So I don't know what we're going to do to that. It's the coolest room in the building, so maybe I'll just move in there. But, our times of, the pendulum will swing back and forth. And then on the structural and the electromagnetic side, the desktop servers or workstations are plenty powerful.
That's something that's particularly changed over the time. Let's be honest, 25 years. It's not that long, is it? If you
no.
And the change is amazing.
Yeah, and it's been mostly. I mean, the software's changed immensely, but I never thought we'd have these GPUs for $2,500 that basically double the speed of my solves. Yeah. It's just amazing. So, we've been running on a Nimbix, a couple of Nimbix machines recently that have, I think they've got 2 GPUs on them, and the turnaround time is just incredible. And the CFD codes are scaling well on these. Not so much on the GPU, but on the multiple cores. And we're starting to see them take advantage of the GPU. The mechanical tools scale really well on the GPU. And we've been really having fun with that.
Oh, don't tell me that. I don't want it to sound like they're having all the good stuff.
Scaling well means on the CFD side we're linear to like, God, what is it now? Like 3,000 cores or something like that.
More than I've got.
Yeah, on the structural side, we're linear to 12, I think. And then if we throw a GPU on, we can get some good performance up to like 40 cores. That's it. That's when it stops. So they're still way behind.
And you guys, obviously, as did you say you was an Ansys reseller or just an Ansys partner or whatever they call it these days? Yeah,
Ansys channel. We call ourselves channel partners.
So do open source tools come into your world at all, or have you?
Yeah, it's an interesting question. So outside of Ansys, we're heavy users of open source. And if I had my druthers, we'd use more of it. So our CRM, our databases, a lot of our simulation tools and non-CAD. Of course, we have to use SolidWorks because that's what our customers use. Yeah. A lot of those tools, a lot of the tools we use on the 3D printing side are open source.
Oh, really?
Or academic. So we'll use a lot of lab codes. So we still do use some government lab codes, that the U.S. government has written and that you can buy from them for kind of the fee of I think it's the fee of what it used to cost to put it on tape, but they've kept the cost for the download. So we do use a little bit. We use, some of the engineers more than others use, open source tools around pre and post processing a little bit. And certainly when we're writing code, we use a lot of open source tools. But when push comes to shove, we use ANSYS pretty exclusively on the simulation side, and we haven't dabbled probably since the Fluent acquisition. We haven't dabbled in any of the open source CFD.
I was kind of wondering whether it comes on into discussions when you're talking to customers who perhaps maybe see something like OpenFOAM or something like that and think, well, can we do what we want to do without the license cost? Or I often wonder whether it's even on the radar of users, if you like, as opposed to CFD nerds.
It's definitely on the minds of the consultants. So they're the ones that will use, they may lease ANSYS for a little while for something, an ANSYS tool for something they can't do with the open source, but they'll use a lot of open source tools, or they'll use old tools where they haven't paid maintenance on it. Just because of the cost situation. Now the cloud may change that. It may be cheaper for a consultant to use commercial code, but yeah, right now you're looking at a huge price difference. I think the other thing that's changed, the reason why we don't see open source as much in the ANSYS world, is we've got something called the startup program.
Okay.
And if you're a startup, you can buy ANSYS for really cheap. And basically whatever you can afford. So we look at your financials, where you are in the funding cycle, and we negotiate a price. So where a startup may have, like we were working with a company that does aftermarket aerodynamics for cars.
Okay.
Mostly Subaru, which is very popular here. I don't know if that's big in the UK, but they were looking at using open source tools, but we did a deal with them using the full ANSYS suite, using the startup package, and so they were able to get access to the full thing. And now that they're making good money, they're paying full price for their ANSYS product. So that's, I think, I was thinking about it the other day. Why are we not seeing as much open source as we used to? And I think that's it. That was a lot of startups who couldn't afford. There was just no way. You could go to your financial people and say, I need $150,000 for this suite of tools, and they would just laugh at you. But now we can bring that price way down. So I think that's been the big change. So we do still see it with consultants. We of course see it in academia quite a bit. And people that are writing custom vertical applications will use open source solvers as a core. And yes, the CFD nerds. We have a couple consultants that we sometimes outsource to, and they're running all sorts of things in the background.
So, I mean, what is almost a fairly subtle change to a licensing terms has had quite a huge impact on usage.
Yeah.
They seem to still be getting to grips, some of the commercial vendors, with the cloud and how they license usage on the cloud. Do you think that's kind of the next thing? Once they've kind of figured that out, then again, it's going to be another reason why not?
Yeah. I think that's the two things that are keeping people from going from the cloud now. It used to be just the hardware wasn't there. Now the hardware's there. So, and if you're a large corporation, there's not a lot of barriers because it's your own IT department is probably more cumbersome than anything else in the world. But if you're a small company, the price model per whatever you want to call it, if it's per hour, per CPU cycle, I don't know if they've worked out what that is. That's still a barrier to entry because one of the reasons why we stopped using solving on other people's computers, and we called it mainframes back in the day, was if I was doing a consulting job and it ran for 2 days and I screwed up and I had the pressure or the velocity going out instead of in.
You're giving me this. I've got the sweats now.
Yeah. You can imagine. You look at your results and you're like, crap, the flow's the wrong direction. And I just spent $10,000 in CPU time. I can't charge my customer for that. They're not going to pay for that. And it's one of the things that killed mainframe rentals, timeshare is what we used to call it, right? So the cloud's got to come up with a more flexible solution. So when I screw up, I'm not paying money.
Yeah.
So I don't know that we're going to solve that problem soon, but people are trying. We've got all sorts of schemes out there. ANSYS will be launching something soon called Elastic Licensing that I'll let them explain when it gets fully launched. But it's a little bit more flexible, as the name implies, on how you can license stuff. I know that like Altair's got their token system, which I think is very flexible and gives you a lot of options. We never compete with Altair on a sale from technology. It's their tokens that always get the customer's interest. It's a really very cost-effective thing. So, and I don't know what Siemens is doing. I really don't know. But they're having to address this as well. So I think you're exactly right. Figuring out the pricing scheme is going to be the next thing. And the other barrier is it's just a pain in the butt to get all the legal stuff done when you're running on somebody else's machine now. Lawyers didn't get involved in this stuff 25 years ago. Yeah. Now they're in everything. And maybe this is less in the UK, but here, we have to sign 20 pages worth of paperwork just to log onto a computer. So I think that needs to be streamlined to where I can just click on something and get access.
Sounds a little bit like we're in the wrong business. We need to be doing the legals.
Every time I'm sitting in a meeting with lawyers, I'm thinking, they make 3 times as much. I mean, I not myself, so much myself, but I look at one of my experts in CFD, like, our lead CFD guy's name is Clinton Smith, and he's really good, PhD, just been doing this for, I think, 10 or 15 years now, and he knows this stuff inside and out. And he's making 1/3 that this lawyer who we're finding typos in his document is making 3 times as much, and we're still proofreading his contract. Like, we should have been lawyers, but oh well. It is what it is. I do like going to work every morning. I don't know that they do.
Well, that kind of leads me into the next one, because I don't get to talk to that many consultants. So when I do, I've got to pick the brain, especially if they've been doing it for a while and they obviously know a few of the tips and tricks. But it feels to me like customers are perhaps doing more of their own simulations that perhaps they might have outsourced a few years ago, and that consultants need to be finding those higher value projects and doing that extracting that value from the tools. Is that your experience? And how do we rise up that
Definitely.
chain?
Yeah. I think 2 things have happened. One is, like we were talking about earlier, the tools have gotten so much better and the hardware's gotten so much better that they can do a lot of it in-house. Also, the reality is there's low-cost providers out there. There are literally rooms of people in lower cost countries who just run CFD 24/7. And some of these larger companies, especially that want to do, 15 different configurations of some piece of geometry, they'll just outsource it to somebody in China or India. And now we're seeing other countries that are even cheaper than those, where they're very talented people and they cost, 1/8 per hour that a US or a European user costs. So, that's where we've seen a lot of the low-hanging fruit go.
Interesting.
Less so being done. This may be a U.S. thing, but less so being done here in the U.S. and more so being outsourced to offshore. And the engineer, the CFD analyst here is designing all the runs that he wants, but they're being done overseas, where everything's just cheaper. So we've lost a lot of work to that, more so than in-house. With smaller companies, it is the tools are good enough to where they just don't need somebody to do it outside. So yeah, we're moving up the value chain. It's either helping them be more efficient or solving these really difficult problems. Like we have one right now that's a water treatment facility, and they're mixing a chemical into the water, and they want to know, after it goes through some baffles and falls over kind of a little waterfall and goes into a new pond, what's the concentration look like in that pond? That's really been a tough problem. And we got it working. And they tried to do it themselves and never could quite get it to go. So those are the kind of problems that we're doing more and more of on the CFD side, and certainly on the electromagnetic. And then when it comes to mechanical, we only get nasty problems because mechanical is so much easier now than it used to. I mean, it has almost gotten to push a button type of simulation on the mechanical side. So it's got to be a nasty one to send out.
So you know when they call, trying to get the headache pills out.
Yeah, we know it's not going to be easy, and it's funny. We had an aerospace customer who was our contact at this large corporation, and he kind of disappeared. And then we got this nasty, painful job, and we made very good money on it. We spent half of it on aspirin, as you say, but it was a really tough job, and it was a real struggle. And we did get it to work. And I ran into this guy; he had transferred to another group, and I'm like, "Why did you transfer to the other group?" And he said, "To get away from that problem." I did not want to deal with that, and I'm so sorry that you guys ended up with it. I thought they were going to drop that simulation when I left the team, but they decided to give it to you guys instead, and you were foolish enough to say yes. So there are some bad ones out there.
So that being said, have we got any advice for somebody who's crazy enough to be thinking about starting a CFD company today? So maybe starting a consultancy. It's kind of the easiest business to start, may not be the easiest business to continue with after you put your shingle up and say, give me some CFD work. But if somebody is crazy enough to go that route, what's the sort of key skills that they're going to need apart from being able to do CFD?
I think one piece of advice that I will give, and we did not follow this, and we struggle with it all the time, is specialize in an area where you know the industry. So maybe it's like rocket nozzle design. Yeah, you may come from a rocket nozzle company, or you may be chemical mixing, or you may be combustion. Stay focused on what you know beyond the CFD, because those are the problems that people are trying to outsource. And we're very general, so we have to pass on a lot of those, or we refer them to the specialists. So if it's a 1 or 2 person shop, I highly recommend that. Just be really good at know the industry, know the terms, know the problems they're trying to solve. Turning the crank on the CFD is really hard to do, and you got to be good at it. But it's useless if you don't really understand what they're trying to do and don't speak their language. So that's a biggie. I think the other thing is you got to learn to sell. And we thought naively that we're really good at what we do. We have a lot of people know us and said, yeah, if you guys start a business, we'll send you work. It doesn't work that way. And we're nice too. It just doesn't happen. So you have to sell. And even the companies that we work with that are individual contributors that are, have their own consulting company, it's not the same thing as selling a car, but you're still constantly building relationships, making sure people know that you know what you know, making sure they know you can help them. Because the problem with consulting business, and when I get done talking, I'm going to recommend a book that I think is perfect for this consulting business, is you have to have gotten trust with the person when they need your help. And the problem is when you meet them, they don't need your help. It's 6 months to a year down the road where they go, oh crap, I need a CFD simulation on this. Uh-huh. Who knows CFD? Who do I trust to do CFD? And if you haven't built that relationship and kept that relationship, they're going to go with somebody else. It's pretty rare that people go on the internet and Google CFD consulting and then get 3 quotes and pass out a job. Even if they find you that way, you have to spend weeks, if not months, building trust with them. And the book that we learned this the hard way, and then one of my engineers said, you should read this book. I think it would have been really helpful 25 years ago. And I'm looking it up right now. And it would have been brilliantly helpful. It's called How Clients Buy: A Practical Guide to Business Development for Consulting and Professional Services. And these guys are mostly accountants and lawyers, but it's the same problem. And they really, I would have killed for it 25 years ago. We would have grown faster and had less headache. The business side of things, if you build it, they will not come. You've got to get out there and let people know you're here, share your knowledge, build relationships, and then get business. And then once you do a good job, they come back. But getting that first job is really hard.
So I'll put a link to that in the show notes. The other thing I'm going to put a link to in the show notes is your podcast, podcasts. Can you give us a bit of an overview of what that's all about? You've been doing that for a while now, haven't you?
Yeah, it's been 2 years now. I just realized that it's been 2 years this month. So we started it. It's funny. We started our podcast because we started selling ANSYS in Southern California, and we could never get engineers in Southern California to pay attention to us. So we thought, well, what do people do in Southern California? They sit in traffic all day. Let's do a podcast. So it's called All Things ANSYS. And it really started early on as a, hey, buy ANSYS from me, and nobody listened to it. So now it's really for ANSYS users and users of all kinds. But most of our listeners are in the ANSYS community or have been in the past. And we interview, like I interviewed John Swanson, who's the guy that started ANSYS and wrote the first program called ANSYS. It was a structural code. I'm interviewing the two gentlemen that wrote CFX tomorrow, actually, of all things. So we're shifting a little bit to talk more about user experiences, tips and hints. When a new product comes out, we'll get on there and talk about the new product. Interview developers from ANSYS. Had a great talk at the Turbo Expo about a month and a half ago, where I've got a user that works that used to be a CFX developer and now kind of is a product manager at CFX, and then a user for a consulting company in the UK about the history of CFD and how that's all gone. And it was a great talk. So we're really kind of shifting it more towards our thought being if we met up at a conference and we're in a bar, what we're going to talk about. That's kind of our theme.
Yeah, absolutely. So if you're listening to this, you should be listening to that. So the link will be in the show notes. The link to the book, everything that we mentioned, will be in the show notes. But if somebody's particularly interested in reaching out to find out more about what you guys do or to contact you directly, website, the place to go. Again, probably the link in the show notes.
Yeah.
But, LinkedIn, is that a good place to catch you guys?
Actually, for me, yeah. So if you want to follow myself and what I'm up to, so the podcast gets posted there, as well as I do a weekly article on the business of technology, and kind of all sorts of crazy things in our local business journal, and I post those to LinkedIn. My last article that was really popular was my mobile office, what I carry in my backpack when I travel around the world, doing engineering and business. And I carry a lot, as you would imagine. Now that I'm not doing simulation, my laptop's about a quarter the size, but I do remote in to run ANSYS and Fluent. So that's a big change. But anyway, yeah, so it's all on there. And if you just go into LinkedIn and look for Eric Miller in PADT is the company, and you'll find me in LinkedIn, and I accept everybody who's not trying to sell me Tupperware or something. So awesome. Do connect and check out our website at padtinc.com, and would love to hear from folks and spread the word of CFD. You know, I think it's becoming it has become mainstream. When we started, CFD was kind of a rarefied thing, and now most of our customers that have some sort of gas or fluid flowing do some form of CFD. So it's good to see.
So at least people know what we're talking about now.
They do. You know, we used to come in and say, we're here to talk to you about simulation, and we talk about the mechanical side, and they go, yeah, and then we talk about CFD, and they go, what's that? You can do that? Yeah.
Stuff of the future.
Yes, exactly. In fact, check out ANSYS Discovery. Have you checked out the ANSYS Discovery live tool?
I haven't used it, but everything I've seen on it is kind of mind-blowing.
It is mind-blowing. It's for those that haven't seen it, it is real-time CFD. It does structural as well, but the CFD is really cool. So you change a baffle, move something, you can see the flow change. Accuracy, you know, it's there. It points in the right direction. I would not optimize my design on it. I'd go to full CFD for that. But you know, we're going to see more of these GPU-driven solvers that give us real-time CFD. So I'm so excited about that.
Yeah, it's good to have something to be excited about, especially in our space. I really want to thank you, Eric, for taking the time to come on. It's been really good.
It's been a fun chat.
You can tell you do this regularly.
We have fun. We do enjoy ourselves. I didn't say this when we started, but the whole reason why we started the company is we wanted to go to we wanted to create a company where we wanted to go to work in the morning, and we do love this stuff. It's so much fun. So I cannot complain.
Yeah, amen to that. Awesome. Thanks again.
All right, thank you. Really appreciate it.
As you can tell, Robin really knows his stuff. He knows CFD, and we highly recommend that you add CFD today to your subscriptions of podcasts to kind of keep on up with what's going on in the broader CFD world. We kind of cover a little bit of the ANSYS CFD world, but he's covering the whole thing. So please do take a listen to what he has to offer and learn from his podcast. He's a good guy. We're not going to do a silly commercial again. We've stopped doing those. So just as a reminder, do please consider PADT as your ANSYS partner if you are in the southwestern United States, including all of California. Also, please think of us as a provider for your 3D printing services, scanning, product design, and of course, simulation training, customization, and consulting services across all the physics. We are here to help. Please do send us an email or pick up the phone and talk to us about what your needs are. We're here to help you do that. Also, if you are someone in the ANSYS ecosystem, not necessarily a user, but you've got a product or a service you would like to advertise on this podcast, please reach out to podcast@padtinc.com, and we would like to share our advertising package with you. We've put something together. We've got a couple people signing up, and we'd love to have you do a 30 to 90 minute spot or do a 30 to 90 minute spot for you on our podcast. It is a very inexpensive way to reach over 300 ANSYS users every 2 weeks. And speaking of 300 ANSYS users every 2 weeks, what are the stats for 2019? So as of this morning, January 10th, we had 16,406 downloads, which puts us at 309 per episode. And our most popular episode is still the interview we did with John Swanson at 774. And number 2 and 3 are the first episode, actually. Topological optimization was the topic, and it was our first as well. So I think that's one of the reasons why it's so popular. That's 620. And then number 2 is episode number 3, which is actually the third most popular is also episode number 3, which is scripting with ANSYS customization toolkit. So customization is always popular, and we'll look at readdressing that in the coming year. We had 605 downloads of that one. Geography-wise, 48.4% of you, so just under half of the listeners are from the U.S. Our number one country outside of the U.S. is Germany, Danke. That's the extent of my German knowledge. 4.8% in the UK, 4.2% in our northern neighbors in Canada, and 3.3% from India, and then a lot of people from all over the place. We did have 5 downloads from Morocco last year. I'm hoping that we have a user in Morocco, or maybe it was somebody on vacation that was sneaking in episodes while they were on the beach. We'll have to see. We will probably never know, actually. And so we thank all of you for listening, and please let others know about the podcast so we can add. Let's talk about the ANSYS stock. Today, which is January 10th, as I said, ANSYS closed at $260.80. But it peaked at an all-time high during the day of $263.06. So it broke through that $260 layer and went to $263.06. For 2019, it closed at $143 a share. Actually, take that back. January 2nd, at the beginning of 2019, it was $143 a share. That's what it closed at. And then at the end of the year, the last trading day was December 30th, it finished at $256.80. So that's $113 per share in growth. So if you invested $1,000, you bought 1,000 shares, you would have made a crap load of money. But if you just bought one share, you would have made 113. 10 shares, I can do that math. You would have made $1,000. 79.6% growth. Kind of hard to beat that. The S&P 500 over the same period did 28% growth. So ANSYS grew 2.8 times more than the S&P 500. So it was a good year for the stock market in general, but a better year for ANSYS. Looking at some of the other companies in the sector, Altair, which is the closest to what ANSYS does, they started at $26.76 and finished at $36.13. So that's 35% growth. So a little bit better than the S&P 500 as well. So the industry is doing well. Autodesk grew to $183 from $128, which is 42%. Dassault also did 41%, very similar. And PTC, unfortunately, saw a little bit of a drop in the middle of the year, the second half of the year, and they're down 12% for 2019. Market cap wise, ANSYS at that $160 a share, $260 a share, big difference, is worth $22.3 billion. Altair is worth 2.7. For some comparison, Autodesk is worth a little less than twice what Ansys is at 42 billion. Dassault is worth 40 billion. And Dassault Systems, not the aircraft company, but the CAD company or the PLM company. And PTC, which is a PLM/IoT company, is worth 8 billion. So Ansys, believe it or not, back in the early days, we always thought that PTC would buy Ansys, but Ansys is now worth more than twice as much as PTC on the market. So how things have changed. So we'll talk more in detail about financials when Ansys puts out its numbers, probably sometime in the middle of the quarter, probably in February-ish sometime. So until then, we'll just watch the stock price go. And as I always say, I don't understand why things go up and down. And the people that are buying and selling the stock don't really know what Ansys does, but they like the business model and they like the numbers. And what it means to us is more developers and more focus on making customers happy, because that seems to be working for Ansys. They continue to help them grow. News-wise, there's really not a lot of Ansys news. The biggest one is that they've been at CES, the Consumer Electronics Show in Las Vegas. So they did 2 press releases. They're really focused on automotive there. And one was with FLIR, F-L-I-R, and the other was with the folks at BlackBerry. And BlackBerry is working on the next generation of vehicles. And so what's next with vehicles from an electronic standpoint? So Ansys, they're using Ansys to do that. And then, of course, FLIR is on the infrared side of things, infrared cameras and sensors and things like that. And they've been Ansys users for a while, and they announced a more strategic arrangement between the 2 companies going forward. So two important announcements in that world of autonomous and next generation vehicles. On the blog, there are 3 articles that I want to point out that I think everybody should check out. One is called Using Rocky DEM. That is the tool that's a discrete particle modeling tool. And so like rocks in a wheelbarrow or marbles rolling on the floor, lots of marbles. It's really a cool tool, and it's a really good article that explains how to use Rocky DEM with Ansys products and basically how to get loads from Rocky DEM into your Ansys model. I just wish we had more customers that needed it. We just don't have that many in our territory, and we'd love to do consulting and such. So if you're doing a coffee roaster or a rock tumbler or anything that's got a bunch of particles like, I don't know, potato chip manufacturing, let us know. We can model that with Rocky, and we'd love to take a look at it. The second article I'd like to recommend is Firework Combustion Formula Can Make New Year's Eve More Spectacular. So one of the combustion experts in the Ansys family wrote a really cool article about how fireworks work and combustion in fireworks. Really check it out. And then my favorite of this last couple of weeks of articles is 5 movies to help engineers explain simulation. So the idea being your relatives have no idea what you're talking about. You talk about simulation, and they picked 5 movies. I kind of agree with these. I have to sit down and think about it a little bit longer. Some of it's more visualization and less predictive, but we won't argue the details. So in their opinion, number 5 is Ender's Game. Number 4 is Ready Player One. Number 3 is The Matrix, which was a simulation. Oh, wait, spoiler alert. Number 2 is Iron Man. They do show some pretty cool stuff with simulation in Iron Man. And number 1, of course, is Inception, because that's kind of what it's about as well. I think all are great movies, whether they really help explain what simulation is about or not. They're cool movies. On the PADT blog, we actually got a couple articles out. We got one more coming out next week. The first one is Defining Antenna Array Excitations with Nested If Statements in HFSS. So if you are working on that 5G stuff or any kind of high-frequency electromagnetic antenna design, do check this out. Seema, who's one of our experts in high-frequency electromagnetic simulation and antennas in particular, wrote this really good article based on some helping some of our customers learn how to do this. So do do check that out. The number 2 was Getting Bulk Properties for Repeated Structures in ANSYS Mechanical and Material Designer, and that's from Alex Grisham. And basically it's looking at kind of this lattice structure stuff that we're doing more and more of. How do you model that as a bulk property? And so if you're working with, it's using Material Designer to do that. So any kind of repeated structure that you want to not model all the details and turn into a bulk property. A really, really nice article. Check that out. Very, very interesting for those of you doing additive manufacturing with lattice structures. And then we also, on our blog, launched the 3D printing glossary. It's at www.padtinc.com/blog, as is all these things we've been talking about with the blog. And it's basically 250 words. And we actually rounded it. We added one more yesterday, so we got to 250 words that are used in the additive manufacturing or 3D printing space, kind of defined. We were looking for a resource to do that, couldn't find one, so we decided to write our own. So do enjoy that. Please do share it with your friends and help understand the world of additive manufacturing. Upcoming event-wise, we've got one webinar scheduled Thursday, January 16th. We're starting the year with a seminar entitled ANSYS IcePack and Sherlock for Temperature Cycling. So if you do anything with printed circuit boards or electronic assemblies of any kind, you need to check this out. We love Sherlock. It's a new product that was acquired either last year. I think it was last year it was acquired. The more we use it, the more we love it. And of course, we've always liked IcePack, and we continue to promote that. So we're going to talk about doing thermal cycling with both those tools to make sure you have more robust electronic components and electronic assemblies. Other events that are going on in the PADT world, I'll be down in Tucson at the end of the month for the AZ Photonics Day on January 29th through 31st. And I'll also mention that I'll be at the ANSYS Sales Kickoff meeting in Orlando. That's not for customers. It's for ANSYS channel partners, ANSYS direct employees, and partners, technical partners. So if you're going to be there, if you're a listener, you're going to be there, stop on by. Would love to get a critical mass of 3 or 4 people to find a corner and record an episode. So reach out to me if you're listening to this and you're going to be at the Sales Kickoff. Then we're holding our 2020 Tucson ANSYS User Conference on February 5th down in Tucson. So if you're a customer of ours in Southern Arizona, or even if you're in Phoenix and you want to drive down to Tucson, do check it out. You should have gotten an email about that. But if not, check out our events page at padtinc.com/events. And I will be, along with a bunch of other folks, including most of our California team off and on, at the Pacific Design and Manufacturing Show /MD&M West 2020. And we'll be there for that. Stop by our booth. This is the 3rd year we've had a booth at that show, and we love talking to our users that come. So a lot of you do check it out. So in conclusion, I want to thank everybody for listening once again, and we hope that you stay with us through this year as we expand and grow the ANSYS world and the PADT world. I also want to take a little bit of a time to talk about some tragedies that have been happening recently, both natural and man-made, and they happen all the time. I mean, every week you could find something to get upset about. Right now, this weekend, I was Wednesday, I think it was, I was noticing that the fires in Australia were just horrible, and those have impacted people we know in Australia. The plane that went down in Iran actually did impact people we know. There were Canadians on that plane that were friends and colleagues of people that are near and dear to us. And the earthquake in Puerto Rico also impacted some folks that are from Puerto Rico. So, we see these things on the news. Try to remember that when you see them, that it does affect people. With the people that are affected by it are people that have friends, family, and colleagues, and they're impacted. And so we really want to take just a second to send out our deepest sympathies to everybody dealing with loss or displacement, not just in those 3 events, but in events in general. So that's kind of a down note, but hopefully letting people know we're thinking about them. Don't forget to subscribe at www.padtinc.com/opt-in and spread the word. Tell people to subscribe. Don't hesitate to reach out if you have any questions, comments, or suggestions. Thank you for joining us for the All Things ANSYS podcast, episode 54. As a reminder, this podcast is not affiliated in any way with ANSYS Inc., and the opinions expressed are those of the people on the show only and not of their current or former employers. For more information, visit www.padtinc.com/blog, and please share your thoughts and questions through an email to podcast@padtinc.com. PADTinc.com. See you next time.